Welcome, John Inness. Thanks so much for giving us some of your afternoon. Please start off by sharing with our audience a little bit about who you are and how you came to be involved in space.
So I'm John Inness. I'm a Guidance Navigation Controls, or GNC for short, engineer at Marshall Space Flight Center, or NASA. Sorry, I'm horrible with this kind of stuff. D- one disclaimer: I am not here officially representing NASA in any capacity. I am here on my own personal capacity.
That's great.
Yeah.
We
So
appreciate that. So, did you always want to be an aerospace engineer? Did you always have a love of space?
Well, it's kind of a complicated. So, like, I knew I wanted to be an aerospace engineer back when I was in elementary school. So,
How in
I didn't.
elementary school, like because I'm thinking back to when I was in elementary school and I was like, well, of course, maybe I just didn't know these kind of jobs existed, but what was it about engineering that drew you even as a young child?
Well, when it comes down to it, I'm essentially a combination of my two grandfathers. So, one of my grandfathers was a fighter pilot, and then after he was a fighter pilot, he was an aerospace engineer. Then my other grandfather was a professional musician turned teacher. So,
Wow.
So I was well aware of that kind of thing, and my father is a computer science major by trade, went to IBM, and he worked on the space program and was working on the International Space Station back when it was Space Station Freedom.
Wow, that's the 90s. That's way back at the beginning. Very cool.
Yeah,
Bet you had a
Uh,
lot of stories around the dinner table when your family would get together and share.
yeah. So
did they say this is a field you should go into, or did you say I want to do this kind of work?
it was something that I chose myself. In fact, I was actually in some ways discouraged pursuing aerospace engineering. Because when it comes down to it, aerospace engineering is such a broad topic that it's like you're engineering aircraft, engineering spacecraft, all of that stuff. There's a lot of different facets that go into it. So you have like your electrical engineering for all like the circuit boards and power systems that are on board. And you also have all the programming with computer science. So only like a little bit of what you get in aerospace engineering classes are actual aerospace stuff. So it gives you a small snippet of it.
Right, right. So you're basically a composite of mechanical and electrical and a computer science engineer.
Yeah, but I went to North Carolina State University. So, and for the aerospace program, it was mostly a spin-off of mechanical with more fluids. And yeah,
Would you say NC State? Full disclosure, I am an NC State alumnus as well, and we're not saying that John has special rights and privileges today, but in my time, it seemed like NC State focused more on the fluids, like in an atmosphere or underwater, like aircraft, rotary jets, aircraft, things like that. Is that still the case, or did in your time, because you're 30 years later, are you seeing a little more entering into the aerospace world, space itself?
well, back when I was there was slowly more venture into space stuff. And for my final year, I was one of the team leads for the first ever CubeSat senior design program, which was a little bit intense to deal with, but we got through it, and there have been an increase in different space course offerings. So orbital mechanics is one of the classes that they offer. They also offer a space exploration systems class as a special elective that you can take. And they've also recently hired a rocket propulsion professor that came in after I left.
Wow,
Yeah.
that's exciting because I know from the NASA's CubeSat Launch Initiative program, North Carolina is one of the 8 states that have not launched a CubeSat yet, and I would like to help change that. We should change that. So I'm certain, and I'm hoping that NC State's going to submit a proposal soon.
Yeah, that was something that our senior design professor threw as a possible option for us to do. But with the current capabilities and like the knowledge base, we needed to build some foundational steps, which that was what I was trying to help him do into the team and creating that foundation that future teams could build off of.
Right. And what was that professor's name? Just we'll throw his name out there. The guy that supported you with your CubeSat design.
Dr. Iwari.
Thank you.
Well, I want to talk a little bit about the various programs. I know you can't share all kinds of, certain information is going to be classified or whatever, but can you tell us a little bit? I mean, I know the SLS I've heard of, but some of the others that I mentioned in the intro, I have not. Could you share, is there anything you can share, just general information on some of these big programs that you've had a chance to be part of?
So HLS, or Human Landing System, is the next generation of lunar landers. So we are going back to the moon to land the first woman and first person of color on the surface of the moon. So currently that is slated for as part of the Artemis 3 launch. Then Solar Cruiser, that is a solar sail. That's personally one of my favorite projects that I have worked as part of. It's a 1600 square meter plus sail.
Wow, that's a mile on each side, right?
No, square meters. So about 40
Oh,
meters by 40
oh,
meters.
1600 square meters. Oh,
Yes.
I was like 1600 meters on the side. That's impressive. Wow. Okay, so your solar sail, vertical landing on the moon. Was there another program in there?
SVGS, or Smart Video Guidance Sensor. So this is an in-house product that we have at Marshall that we're trying to do some spin-offs to the industry. So it has several different applications. So one of the demonstrations that we've done has been a high altitude. We're going to be doing in the new year is a high altitude drone landing, where it's actually going to be landing precisely without the use of GPS. It's just navigating relative to this sensor.
Is it
That's cool.
like a visual sensor or another
Yes.
technology? Okay.
So it's essentially, I don't know how well you can see my hands, is you have 4 LEDs, so you have them in a specific pattern. Then you can process those using photogrammetry and use that to give you a relative 6 off state, so 6 degrees of freedom.
Wow.
So your attitude and your position off of it.
That's very cool. I know I want to ask you about how we land on the moon in a certain spot, but I want to ask you, if you were teaching really young kids and about GNC in general, guidance and navigation, I always think of it as where are you and how do you get to where you're going? But I always think of two components, and I was hoping you might elaborate as if you were talking to rookies, which basically we all are. You either have sensors or actuators, right? Is
Right.
that sort of the base of where you start with guidance and navigation? How you take in information about where you are, and then how do you make changes about where you're going?
Yeah, so it's GNC, but the actual process flow, as you were implying, goes navigation, guidance, and then controls, but NGC doesn't roll off the mouth like GNC does.
Okay, so it's you're going somewhere, right? Let's speak in broad general terms about a rocket, right?
All right.
First stage return for Falcon 9. Are you able to speak about that in any way, the SpaceX, since that's not really your employer?
That's I can't really speak to that.
Okay. How about this? How in modern rockets, how do we know which way our rocket is pointing or in what direction we're traveling?
So that is like we have something called an inertial measurement unit. So it's checking your different accelerations. So as you're like moving, it's detecting those tiny movements, and you can use those to combine and add those up, and you essentially get your combined like how you're oriented and how fast you're going and where you are.
Awesome. Are
So
they solid state like Navy? In the Navy, they used to use these big gyroscopes, so the submarines would know where they are relative, like under the ice, under the ocean. Is the IMU gyroscopic, or is it of a similar kind of thinking, or what could you share about IMUs?
I am not familiar with the exact details of like what do we use, but like what we use for attitude determination are called rate gyro assemblies, or RGAs.
Okay, awesome,
So
awesome.
I have a layman's question. So when we're thinking about navigation, right? And obviously you've mentioned sales, you've mentioned the idea of the drone, the videos. How does one determine, like, what is the need for figuring out how you're going to navigate? Like, how do you determine a sail would be better here versus, say, operating it from other? Can you tell me a little bit about that? That I'm clueless.
so it largely depends on like your mission needs. What are you wanting to do? So A sail has certain advantages. You can also do an unpowered probe that you just send out on a set trajectory off of your launch vehicle. It all depends on what your mission needs and goals are. So the nice thing about sailcraft, so you have your solar sails and your electric sails. Not sure if you're familiar with electric sails at all, but those essentially provide a constant acceleration that you have propellantless. So you don't need to bring anything with you. And that allows you to have different orbits that you can do. So if you have like the sun right here, you can do essentially a special halo orbit where you're orbiting like that around the sun versus doing a conventional around the sun.
So
Uh,
you can be above the plane of the ecliptic with your
right.
solar sail. That from what I think I know, that's very energetically expensive, right? To have an orbit that's not in the ecliptic, which where all the planets are.
No,
The
okay, got
planets
that.
are in
Right.
the plane.
So when is a time where you would want to be optimizing that? Like when you're talking about like choosing the right form of movement for the mission, when would you make those decisions about a solar sail versus an electric sail?
So solar sails and electric sails are very early conceptual design. So electric sail is way further behind. It's a different concept. So let me see. I don't have an easy piece of paper that I can grab
That's
in
all
front.
right. When you say they're early, this is over the horizon. Are you talking 10 years, 50 years, 100 years?
So what I'm talking about for solar sails is solar sails have been flying since like I don't remember the exact first mission, but there have been different NASA launches that have done studies in low Earth orbit in the early 2000s. And then with Artemis 1, Near Earth Asteroid Scout or NeoScout was launched as part of it. But sadly, we have not heard anything back from NeoScout and is right now presumed lost.
Yeah, space is hard, right?
Yeah.
I know I read at least 50% of university CubeSats don't power up, on orbit, and space is hard, right? So we're
Oh, 100%.
So I think the sail is like in general, just kind of like that's how you can navigate to go certain ways.
So,
How does that work with you had mentioned the video kind of drone kind of one too?
well, that's
no,
that's
That's just
different.
controlled
two
on.
completely separate things. And solar
Okay,
sails and electric sails and sailcraft in general, that is more of a propulsive
propulsion.
mechanism versus an actual GNC mechanism. It does have a lot of fun GNC problems with it, but it's something entirely different than
So a
GNC
different
related.
system, different kind of
Yes.
system. Got it.
So let's pivot a little to vertical landings on the moon. We now, am I right? The moon does not have a significant magnetic field, so you can't really maybe manipulate, use the magnetic field of the moon like we do on the Earth to help us with, say, attitude control.
I'll be fully honest and say I do not know. So.
Okay, an engineer that just says, I don't know. Okay. Well, you can't get in trouble for that, can you? So how about this? When we decide we're going to land somewhere on the moon or another body, the geography, the cartography, right? The maps are critical, right?
Yes.
Especially on a place we don't have a lot. Do we know a lot about the South Pole on the moon, or what do we know or don't know that we're going to learn soon when we get there in person?
So there's a whole lot of unknown with the South Pole. So like one of the challenges is because of how the moon rotates, it's tidally locked to Earth, where or the Apollo astronauts were just landing on the surface where they would have essentially normal shadows. Versus when you're down at the South Pole, you're going to have a different set of issues where you're going to have this long shadow that extends seemingly forever, just because you have the moon right here, and if you're right now where the sun is, you're having the sun rays just come directly at you, so it's just going to wrap around. So it's going to create a challenge with navigating because you can't necessarily visually see what a crater looks like.
So there's so much darkness because of it's the sort of at a tangent, right? The sunlight is
Yes,
at a
exactly.
tangent. So we get these really long shadows which impede what you can see in the darkness.
Right.
Very cool. Yes.
And and that leads to a whole other host of issues, such as your thermal issues, because you'll have one side always facing in the sun, then you'll have the opposite side in the darkness where it's extremely cold. So you have to deal with those thermal control problems, which I'm not familiar with.
Yeah, so you could if you could park yourself halfway in a shadow in a lit spot, you could just sort of rotate to heat. But yeah, that will be very and there's what 400 degrees of temperature difference between the shadow and the sunlight.
If I remember right, that sounds right.
Yeah.
And like fun fact on like the rotating, when the Apollo spacecraft were flying to the moon, they were actually doing a slow rotation to prevent the uneven heating from
That's
damaging
one of
the
my
systems.
favorite lines from Apollo 13 is where they talk about doing a barbecue roll on the way to the moon. That's fantastic. Let's digress just a minute. So you're an engineer, a working engineer at NASA. What kind of science fiction, if you have any interests, what are your happy places as far as movies and sci-fi?
Well, it's all about suspending your disbelief. So it's like accepting like this is not real and going with it. So like Star Wars with a different propulsion, sound in space, that's not really a thing.
Yes. Yes.
Thing, then you can have like The Martian where they try to do a more realistic approach, but there's still some like things that aren't necessarily yeah, true to life. So it's like the massive dust storms and like being able to blow over a habitat. The Martian atmosphere is less than about 1% of Earth's atmosphere, so don't really have the possibility of being able to flip massive objects unless you have a giant sail on them.
Right. So there's not enough particles crashing into your vehicle to exert a composite amount of pressure to tilt it. That's
Right.
interesting. You didn't mention Star Trek. I have to ask, as an old guy, as an OG, I have to ask about Star Trek. What are your thoughts on Star Trek?
Well, I will fully admit I have not seen much of Star Trek, so something that I want to see more of, but
I think that as we're talking about like those, as you said, the suspension of disbelief, right? It happens with literature too. And so like even with sci-fi literature, when you think about not only those discrepancies that wouldn't really happen, we kind of get a view of alien life that's always so threatening or is like always out, to get us versus what we would likely see, which will probably be more of microscopic life forms in nature before we would see scary non-green human things or whatever it is that they do. So I think there's that too. Are you able to, so I wanted to pivot to we're talking about what you are doing daily as an engineer. Are you able to share for our listeners who, I know you're kind of a mishmash, you said different things, right? You do different things. What is a typical day in your life that our students who might become a NASA engineer would expect to see?
well, the thing is, there's no typical day. So it's like I'm a relatively early career, so I started full time in 2020. And one of the things here at Marshall Space Flight Center is that we have the Professional Intern Program, or PIP, where we go on rotations to different groups. So I went
Oh,
on a rotation to propulsion group, went to testing group, then a GNC hardware group. So I got exposure to like different things that have made me more connected on center. So if I need any help with something in the project, I know I can reach out to this person, and also give me exposure to like what other people are working on.
Oh, so it's like you get to rotate in now, so you experience because there
it,
are
it,
so many different fields within it.
it's like
Exactly.
they're
It's
training
like
you
a
to be a
wheel.
systems engineer. Um, would you say some days are more hardware, some days are software, some days are modeling? Do you ever have silos where you could say my day is more about I'm turning a wrench versus I'm creating something in some sort of CAD software, or I'm running simulations or writing code, or any of those, or all of those part of your days?
So really depends on my days. So right now with my current projects I'm working on, it is mostly doing simulation modeling. So I don't necessarily do CAD. I work in something called Simulink. It's essentially a block-based programming languages that is used a lot for GNC work. So
Okay. What of the rotations you've done, what did you personally enjoy or find most interesting, or anything you'd like to share about your most exciting day thus far in your rotations there at Marshall?
Well, I will say I've been done with my rotations. I had my essentially out briefing at the start of this year for that. But my favorite rotation was to the testing group where I was doing vibrational test analysis, where I helped with different acoustic tests, modal tests, shock tests, and also vibration tests.
Awesome.
So, and as part of that rotation, I actually got to travel down to Kennedy Space Center and help out with the integrated modal test.
Kevin, when you do your vibe testing for the CubeSats, so that's what he's talking about here, right? So there must be numerous problems that can
except
happen.
with much larger devices probably than a
yeah.
CubeSat. We the old timers told me a shock test, they would bolt down whatever they wanted to test and they'd hit the edge of the table with a hammer. We're probably a little more advanced than that now, right?
Well, there's been 3 different methods that have been used for shock testing at Marshall. So like one of them has been doing like bolt it to something, get a sledgehammer, and then bam. Then the other one has been more like using pyrotechnics to induce a shock onto it. And then something that I got to help out with was a pneumatic shock cannon, where it would actually shoot a metal slug against a metal plate. And that
Oh, wow.
would
Yeah, because those would all be very different.
So it also depends on what element you're testing and where it's located within the rocket itself, right? Not every part of the rocket would experience exactly the same type of vibrations. Am I right or wrong on that?
you are right on that. So like different parts of the rocket experience different loads. So one of the things that we have to do for when designing something to load, so like one of the things I helped with shock testing was flight termination system battery. So in case things went wrong with Artemis 1, this battery would be engaged and essentially self-destruct the vehicle.
The battery probably sends us voltage to some charge, right? It's the battery. It's not dangerous. It just
Exactly.
powers the.
Exactly.
Is it true the Air Force controls the button on that? The range control? Is it an Air Force guy that would press the button on that, or a NASA guy?
That is a good question. If I remember right, it is a Space Force guy. So, all the mismatch with the Space Force. So essentially, Space Force is stepping in and doing what all the 3 services were previously doing. So like Army had some space people, Navy had some space people, Air Force had some space people. So just put it under one roof to do Space Force.
Right. And the 45th group is at Patrick Space Force Base, and they're right there at KSC. By the way, you have a fine tradition in Huntsville with the Redstone Arsenal, right? So there was a lot of early rocket development there in Huntsville. How have you enjoyed living in Huntsville? Because there is such a good tradition with America's space program there.
Well, I absolutely love it here in Huntsville. So there's a lot of different things that I personally find enjoyment in doing. So it's like I have good work here. Outside of work, there's a lot of hiking spots. There's music opportunities. So it's like I play in a couple different orchestras, some bands here. And there's
have
also,
you walked past von Braun's house, that little white house, the street where all the German rocket scientists live?
I have not. But it was actually for sale earlier this year.
Oh, wow.
You know, we actually work with a young lady, and we should introduce her to you. She wants to be an engineer, but she is also a musician in an orchestra. And she was very interested in the University of Alabama, Huntsville, UAH, because she could pursue engineering and her music. Tell us about your musical instruments that you play or your favorite music.
So I'm a multi-instrumentalist. I play piano, tuba, bass guitar, organ, and a myriad of other instruments. So back in undergrad, I actually minored in tuba performance. So it's like something that I've kept going, and it's something that I highly encourage for others to keep doing. So it's like as much as people think that music doesn't have any relations to like engineering, there's a whole lot of things that come intertwined. So like acoustic testing, so it's like how does sound add up together, because you have to, some of the environments there are like extremely loud, or you have to make things extremely quiet. So we have an anechoic chamber here at Marshall that I actually got brought in my tuba and play some notes in it.
Actually, I'm thinking you must be talking about Celine, right? So like
Mhm.
now as I'm thinking about it, she's looking for her, maybe she could do something where she's testing
Yes.
acoustics
Well,
for space, like on her
yeah,
on her paper that she's trying to work on. That's actually, well, I mean, I always knew about like the musical correlation to math, right? But you know, think about testing the acoustics of something like that. That's
very
pretty
cool.
great. We always kind of round out our interviews by asking, you know, if we have student listeners who might be thinking about going down this path, couple of ways you can go, either advice that you have for young students who might be heading into college in the next few years, or maybe you want to talk a little bit about what they need in order to be successful in any career. It's up to you how you want to, your advice for our listeners.
Well, keep exploring, seeing what's out there. Like for my journey in aerospace engineering, I knew I always wanted to do aerospace engineering, but it's like I didn't know what to do in aerospace engineering. So it's like wanting to explore different options, see what was out there. So there's a whole lot of different options that you can do. So it's like I was saying, you do not need to pursue aerospace engineer to be an aerospace engineer. In fact, if you do like electrical engineering, you are more likely to get an aerospace job if that is something you are interested in. So it just depends on what your strengths and weaknesses are and figuring out what you want to go and how you go about it. So
Very
Yeah.
cool.
Yeah, I think that you're right. It's overwhelming, right? Like just in general, when you're a kid and you're trying to figure out, oh, if I'm going down a path, am I kind of committed to this path? And it sounds like the route that you're taking or within aerospace, it's a really broad path that you can kind of find yourself going in many different directions.
Awesome.
exactly.
John, I want to thank you for taking the time to speak with us today. I really enjoyed it. We look forward to following you, and maybe we can circle back in a year or so and get an update on some of these great projects. But I want to thank you for joining us today.
Of course. Happy
So
to be here.
thanks, you too.